Hello, welcome to week 2 and day 12 of the FYB data analysis training. In this class, we'll be talking about statistical tests like t-test, ANOVA, and non-parametric tests like Mann-Whitney test and Kruskal-Wallis test. So after you've done your descriptive analysis, how would you know the statistical test to run for your research? The first thing is to actually determine the question that you want to answer. And how can you determine the question that you need to answer? Is by actually looking at your research objectives or your research question. So it is either you want to know if there is difference between groups, or if there is association between variables. So now if you are talking about difference between groups, you have to check through your variable. Okay, how many groups are we talking about? Are we talking about 2 groups, or are we talking about more than 2 groups? And after determining this, also you also have to actually determine, okay, these groups, are they related or are they not related? Okay, for example, if you have, just like data we are working with, we have data of students, both international and domestic students. So if you want to know, for example, if there is difference, if there is significant difference in total depression score between the international student and the domestic student, so we are talking about groups that are not related in this case, so we can go this way. So but for related groups, an example will be a before and after study. For example, let's assume we gather maybe 10 people, and then we measure their depression score before, and then we gave them maybe a drug, or a food, or we subject them to any form of treatment, and then we later on measure the depression score. If we want to know if there's any significant difference between the depression score that we measured before giving them a particular treatment, then we have to go this way. So the first thing you need to do is actually to know the question you want to answer, and then to try from there. You can now determine the statistical test that you need to carry out. So this thing that you're looking at is called the decision tree, statistical test decision tree. I'm the one that create this one, but you can also find other comprehensive one online. So for this particular class, we have a research question that we want to answer, and the research question is that is there a significant difference in total depression score between international and domestic students? And also we want to know, is there a significant difference in total depression score between among the students of different age groups? So those are the two questions that we want to answer. For the first question, that is checking if there's significant difference in total depression score between international and domestic students. In this case, we are working with 2 groups, so that, and then those 2 groups are not related. So that means we are either doing a t-test or a Mann-Whitney test, and we can do a t-test if all the criteria for carrying out the assumptions for carrying out a t-test is met, and then if those criteria are not met, then we can do a Mann-Whitney test. Okay, now for the second question that has to do with age group, we have more than 2 age groups, so because of that we are going to go this way, and those age groups are not related. Therefore we'll be using ANOVA if all the assumptions of ANOVA are met, and if they are not, then we'll be using Kruskal-Wallis test. I'm sure we're already familiar with the assumptions for both t-test and ANOVA, but we can just go over it again. So for independent t-test, the assumption is that we have to have 2 independent groups. That one is met. Then there's assumption of normality. We are going to test for that using the Shapiro-Wilks test in SPSS, and then the homogeneity of variance. For this one, the test has a way of actually taking care of that. And then interval or ratio scale data. Our total depression score is a numerical data, and it is actually is measured in interval or ratio scale. So the only assumption that we need to test for, so that we can decide if we can use independent sample t-test, is actually the normality. So we can go into SPSS now and then test for normality for our first question. For the second question also, the we also need to test for normality so that we can determine if we can use ANOVA or if we need to go with the Kruskal-Wallis test. So I will launch SPSS now. Carry out the test for normality. There are like some tests that can be used, but the one we'll be going with is the Shapiro-Wilks test. And to carry out the Shapiro-Wilks test in SPSS, so you'll go to analyze and then descriptive. Then under descriptive, click on explore, and then for this explore now, we have this dependent list box, and then we have the factor list box. The dependent list is our numerical variable, in which in this case, which is the total depression score. So I'll put that inside this box, and then the factor list will be the interval variable here. So I'll put that here. And also we have, you might decide that you want to see both statistics and plots, or you might decide that you want to see plots, either of the two. So also come to statistics. So the statistics is okay. Then coming to plots here, I'm going to check normality plot with test. Actually, this particular step is actually very important. That is what will bring out the Shapiro-Wilks test. And I'm going to change this from stem and leaf to histogram. Then click on continue, and then okay. So after this now, we can see the output that we have. Well, we also have some charts. So we have the histogram that I checked that time, and then this normal QQ plot can also be used to determine normality, but I'll be using this is a box plot. I'll be using the test. This is the result of the Shapiro-Wilks test. This test is also for normality, so there's a way to interpret the two, and there are some criteria for which you can use either of the two. So but for this class, I'll be using the Shapiro-Wilks test, and then the interpretation of this test is that if this sig, which is like the p-value, if it is less than 0.05, then the conclusion is that the data is not normally distributed for that particular group. So for example, for the international student, it is less than 0.05. So that means the variable total depression score is not normally distributed for this, like for the international student, though it is greater than 0.05 for the domestic student. So the conclusion is that it's actually normally distributed for the domestic students. But the point is that the continuous variable should be normally distributed across all groups. That is the assumption. Since that assumption is not met, then that means that we cannot actually use independent sample t-test to actually determine if there is a significant difference in total depression score between between the international and domestic students. That means we need to go for the non-parametric test, which is the Mann-Whitney test. Okay, let's try for another variable. Let's try for the social connectedness score. Let's see if that will fulfill the criteria. This is the total social connectedness score. So okay, wow, it's not even okay. The histogram is even showing us already that this one is not normally distributed at all. You can see the histogram, it is skewed. I will still show us how to carry out t-tests. In fact, that's what I'll show us first, so that after determining if you need to carry out maybe t-test or if it is the Mann-Whitney test, you'll still be able to carry it out. So to carry out t-test, you need to go to analyze and then compare mean. Then now there are different type of t-tests. I'm sure we must have already learned about this from yesterday's video. So in this case, we are going for the independent sample t-test. So I'll click on independent sample t-test, and then we have the test variable. The test variable is the numerical variable that we are dealing with, and in this case, that is the total depression score. So you can put it inside this box, and then you can put more than one numerical variable at the same time. Then the grouping variable is actually the categorical variable that we are dealing with, which is the interdome. So you can put that here, and then you need to define group. So this one will be 1 and 2 because I think our maybe we coded international as 1 and then we coded domestic as 2, something like that. So that's why we are putting 1 2 here. Now click on continue. Then the next thing is to click on OK, and then if you scroll down now, we can see the result of our t-test. So the, so this is the result that will actually come out. This is the kind of output that will come out when a t-test is carried out. And then what is actually most important to us is this sig two-tail part. So this sig two-tail part is actually our p-value. So this place is actually very, very important. And the interpretation is that if p-value is less than 0.05, then we reject the null hypothesis. But if it is greater than 0.05, then we fail to reject the null hypothesis. Okay, I did mention hypothesis before jumping, like before going out to carry out the test. So for this particular question that we are trying to answer, our null hypothesis will be there is no significant difference in total depression score between international and domestic students, and then the alternate hypothesis will be there is a significant difference in total depression score between international and domestic students. So we carry out the test now. We can see based on these results now, the conclusion is that we would fail to reject the null hypothesis. Based on the test, the normality test we carried out, we can actually see that t-test is not actually the ideal test to use in this case. So let me show us how to actually carry out the Mann-Whitney test. So go to analyze, then so after go to analyze, then scroll down to non-parametric test, then legacy dialog, then 2 independent samples. So analyze, non-parametric test, legacy dialog, and then 2 independent samples. Then the box actually looks familiar like the t-test own. So you just need to put in your numerical variable here, and then the grouping variable, which is what I'm actually looking for. It I can't find it here. I'm not sure why interdome is not showing here. I don't know what is going on, but let's go to the data view and let's try to see what is going on. Okay, now the reason for that is because this interdome is coded as string and is meant to be numeric. So I believe when we change it to numeric now, it's going to actually show. It's going to show there. Let me just change gender also to numeric. So let's go back there. I believe it should make sense now. Also, let me change age group also to numeric so that will not affect us. So that's why assigning the ideal data type and then the measure is actually important. So let's do that again. Analyze the non-parametric test, legacy dialog, and then 2 independent sample. And you can see that those guys are now here. Then so group, you put the group thing here to be similar to what we saw with the t-test. Then continue. You can see that Mann-Whitney test is already checked here. So there are other tests that can be used also, but I usually use the Mann-Whitney test. You might want to read up on all the tests and then maybe know reason why one might be preferred over the other in some cases. So now this is the result for Mann-Whitney test, and then the sig two-tail also is the p-value, and then that is what will be used to actually determine the conclusion. And in this case also, if p is less than 0.05, the conclusion will be to reject the null hypothesis. Why if p-value, which is the sig two-tail, is greater than 0.05, the conclusion will be to fail to reject the null hypothesis. So really, that's how to carry out t-test and then Mann-Whitney test in SPSS. It's not actually difficult. It's not difficult at all. The most important thing is actually just knowing, okay, what statistical test do I need to actually carry out, and then actually carrying it out is not difficult. It's very, very straightforward. I think that's that with our first question. So now let's answer our second question, which is there significant difference in depression score across different age groups? So before we go ahead to decide a test So we now for this, we know that because age group contains more than two groups, we are using, either we use ANOVA or we use Kruskal-Wallis test. We are going to use ANOVA if all the assumptions for using ANOVA has been met. But if those assumptions have not been met, then you can use Kruskal-Wallis test. Now the different assumptions for ANOVA has been met except for the one for normality. So we have to check for that one by using the Shapiro-Wilks test. So to use the Shapiro-Wilks test, come to analyze and then descriptive, then explore. Then here factor list will have the age group, age category, and then the dependence list will have the total depression score. So make sure on that plot, normality plot with test has been checked, and then I prefer histogram. So click on continue, then okay, and then we scroll down a bit. We are going to see the Shapiro-Wilks test for normality, and with this test we can see that that particular criteria has not been met, because for age group 16 to 20, 21, and for age group 16 to 20 and 21 to 25, total depression score in those groups is not normally distributed. Therefore, ideally for this particular question, we cannot use ANOVA, then we can go with the Kruskal-Wallis test. But I would also like to show us how to use ANOVA, how to carry out ANOVA test with SPSS. So to do that, we can come to analyze, then compare means, then this time around you choose one way ANOVA, and then the dependent list will be the total depression score, and then the factor list will be the age group, age category, and then, well, for this case we will, okay, let's click on okay, and then we have our results. So these are our results here, and here now what is actually very important to us is this sig, because this sig is the p-value. In this case we fail to reject the null hypothesis because the p-value is greater than 0.05, and that would mean that there is no significant difference in depression score across the different age. But anyways, the assumptions for using ANOVA was not met, so ANOVA is not the ideal test for this. I'm just showing us how to carry out ANOVA in SPSS. So we can go to analyze, and then to carry out Kruskal-Wallis test, also go to Nonparametric, then legacy dialog. Then in this case you choose k independent samples, and then the test variable is the total depression score, and then the grouping variable is the age group. Also, you need to define range. We used 1, 2, 3, 4 to code our age. So minimum is 1, then maximum is 4. Then click on continue. Then you can see Kruskal-Wallis test is already checked there. Then click on OK, and then you will see that the p-value here now, this a sim sync is the p-value here, and it is 0.404, which is actually greater than 0.05. So the conclusion in this case is the conclusion in this case is to fail to reject the null hypothesis, and therefore that means there is no significant difference in depression score across the different age groups. That is how to carry out t-test, ANOVA, Mann-Whitney U-test, and then Kruskal-Wallis test in SPSS. Okay, so we are in Excel now, and then how can we carry out a t-test in Excel? Okay, in Excel, I don't know how we can carry out a non-parametric test in Excel, but for t-tests you can carry out a t-test in Excel and then ANOVA. So this is how you can carry out t-test in Excel. To carry out a t-test in Excel, the data has to be in a particular type of format, so you can actually carry out a t-test on the data that is in this format. So the data has to be this way, so that for the international student, the numerical variable has to be listed, and then for the domestic student it has to also be listed under it this way. So how can we achieve that? So we can just activate the filter buttons here, and then come here, then filter down to international, then click on OK. Then you can now copy the total depression score for international students, highlight it and copy it, then come here to paste it under international students. Then if we come here again, we need to filter down to domestic and then copy the values for the domestic students. Then I'll just come here and then copy the values for the domestic student too. So the next thing to do after this is to go to data and then go to the data analysis tab. Then scroll down and then you have three options for t-test. You have the paired to sample. We are not doing paired t-test. We have two for two sample t-test. So we have the one for equal variance and then we have the one for unequal variance. So we will just go with the one for unequal variance because we are not actually sure if the variance for the two groups is actually the same thing. Okay, we'll quickly go back to SPSS. Here, we have SPSS will release results for both if equal variance is assumed, and then it will release results for if unequal variance is assumed. So based on your variance, which is you can use the standard deviation, you might want to determine which results you want to go for. But let's go back to Excel. So I'll choose this one, assuming unequal variance, then click on OK. Then here, let me just delete this and do it again. So here now you have to actually choose what you want. So here you have to choose what you want. So for the variable range one, I'm going to highlight everything for the international students with the column header, that is intentional. Then for variable range 2, then that will be for the domestic student, also with the column header. Then I'm going to check this label, and then for my alpha, that is the significant level, I want to choose 0.05. Then I want the output should be also in here. So instead of choosing new worksheet, I'm going to choose output range and I'll specify where I want it. I want the result to be pasted here. Then the next thing is just to click on OK, and then this is the result. With this result now, we can see the mean total depression score for international students and then the mean total depression score for domestic students. So then if we scroll down, we can see results for, we can see the test statistics, we can see the degree of freedom, we can see the result if we are running, if the test is one-tailed, and then the result if it is two-tailed. So our test is two-tailed because we are not saying maybe the total depression score is actually greater in one group than the other. We are only saying there's a difference between them. So that kind of test is a two-tailed test. And for this two-tailed test now, the p-value that we've gotten is 0.429, and that is actually greater than 0.05. That means our conclusion is to fail to reject the null hypothesis, which means that there is no significant difference in depression score between international and domestic students. So the p-value here is 0.429. If we go and look at what we have in SPSS, it's also 0.429. So the same thing. So this is how to actually to carry out a test in Excel. Also, there's actually a t-test function. So to use the t-test function, you just use equals t-test, t.test, and then that's it here. Then you need to select the two data sets. So select the column for the first group and then select the column for the second group without the column header. Then you have to specify, we are talking about a two-tailed test here, so two-tailed. And then also we want to do two sample on equal variance, then close the brackets and then enter. Then we still have our result, which is still approximately 0.429, and that means we are also still coming to the same conclusion. Okay, so to carry out ANOVA in Excel, you have to have grouped your data in this way also. So I've just done that before I recorded this part. So you have to have grouped your data this way, in which the data for each group is already like listed under it. Then after that, you can now go to the data tab and then click on data analysis. Then if you scroll up, you will see ANOVA single factor. That is one way ANOVA, which is what we want to do. Then click on OK. So you need to come here and select your data. You can select it with the column header, select everything, and then because the data is in column, so column is okay. Then check the fact that okay, label in first row, because we selected the data with the column header, our significant level is 0.05. Then you need to select where you want the data to be displayed. So I already selected age 3. So if I click on OK now, then the result of the ANOVA has been displayed. The important thing here for us is the p-value. That's what we use in decision making, and since p-value is greater than 0.05, so that means the conclusion is to reject the null hypothesis, and which means that there's no significant difference in total depression score across the different age groups. So if we compare this to what we have in SPSS, the p-value is 0.37, and also here is also approximately 0.37. So this is how to carry out ANOVA tests in Excel. So how can we carry out this test with GraphPad Prism also? Now the first thing with GraphPad Prism is you have different table and graph types here. So which one do we need to go with? We need to go with the column. For this particular type of data that we have, we need to go with column. So we'll go with column, and here it's saying enter or import data into a new table. That's exactly what we want to do. So yeah, this we'll go with this one also. Enter replicate values tagged into column something something. We don't have repeated, like we don't have replicate, so we don't need to choose this one. And then we are not actually entering already calculated mean, so we can just go with this first one. Then we'll click on create, and then this is what we have. So for the first question that we are dealing with international and domestic students, so we can click here and just give the column a title. We can call it inter also, and then for the second one we just call it DOM for domestic students. And now we need to post the data also here, so we'll just choose the data that has been grouped in Excel already, so like this one. So I cannot actually copy them like this, and I'll go to GraphPad Prism to paste it there. So now we have our data here. To analyze your data, then you can go to analyze, click on analyze. But because we've actually not talked about descriptive statistics in GraphPad Prism, so if you want to actually get your descriptive values like the mean and all of that, so you can just, when you click on analyze, you can come under column analysis and then choose descriptive statistics. So then if I click on OK now, then it's asking me what exactly do I want. Well, I want minimum, maximum, range, mean, standard deviation, standard error of mean. I think all of that is just okay. Then it's asking me how many significant value do I want. I think 4 is okay also. Then I'll just click on OK, and then now I have the minimum, maximum depression score, the range, the mean, standard deviation, and then the standard error of mean. Okay, that is good. So what if we want to know, we want to carry out t-test? Then we can also come here, analyze, then still under the column analysis here, you see t-test and non-parametric t-test. So okay, let's go back to the data table first, and then we'll click on analyze from there. Then we can click on t-test now under column analysis. So it's already checked inter and dom for us, that is okay. Then we just click on okay, and then it will bring this. So it's asking us, are we dealing with a paired t-test or unpaired t-test? Since we want to do independent sample t-test, then we'll go with unpaired. And then it's asking us, we want to use a parametric test or non-parametric test. For now, we'll use a parametric test, and that will just do the t-test for us. And then it's asking us, we want to assume, like the assumption of variance thing. So I'm going to choose do not assume equal standard deviation, and we know that standard deviation is actually very much like proportional to variance. Okay, then we really don't need this place. Then options. So we are doing a two-tailed test, so we can go with this two-tailed. And if what you are doing is one-tailed, later on you can choose one-tailed. It's asking us if we want graph. You can just ignore the graph. If you also want descriptive statistics with the t-test, you can check descriptive statistics from this place, and then it's asking for a significant digit here. It is 4 here also, but we are good this way. Then we can just click on okay. And then if you come here now, this is the result. Actually, for GraphPad Prism, I love the way the result is usually displayed. So now it's telling us, okay, this is what we are actually checking for domestic versus international students, and then the p-value is 0.429. That's exactly what we got before, and it's already telling us that, okay, p-value summary is ns means not significant. Yeah, I think it should means not significant. And it's also telling us here now, okay, is there a significant difference at p less than 0.05? No. So we are using a two-tailed, and then so really that's how to carry out t-test in GraphPad Prism. If you want to carry out Mann-Whitney U-test, let's just do it again this time around. Then we'll choose the option for the non-parametric test. Create a new result sheet, yes. And this time around we'll say no, use non-parametric test. So then click on OK, and then it has already chosen Mann-Whitney U-test. Then this is the result for the Mann-Whitney U-test. That's how to carry out Mann-Whitney U-testing. What of the second question for the age group? Then you can come here to create a new data table, and then when you click on plus, it will also ask you what type of data table do you want. We still want column though, so then click on column and then click on create. Then we can also come in to paste our data, so we can go into Excel, and then the data for the age is here, and then I'm just going to copy the data first. Now come here to paste the data. Then for the name of the data set, you can type it manually, or you can also paste it. I've copied the column headers like the age group itself. I'm just going to come here. Okay, I'll just come here and paste it. Then it has actually pasted it also. So to carry out ANOVA, you also go to analyze and then column analysis. Then you can see one way ANOVA here. So it has already checked all the groups, and then you can click on OK. Then use ANOVA. If you want to use the non-parametric test, you can also choose use non-parametric test, but ANOVA is actually okay. And then no matching or pairing, so that's what we want, because we are not doing repeated measure ANOVA, we are just doing a one-way ANOVA. So no matching or pairing is okay. Then you can click on OK, and then it has also given us the results. This is the p-value, and it's telling us that, okay, at 0.05 it is not actually significant. There's no significant difference in total depression score across the different group. Okay, so we've learned how to carry out descriptive statistics with GraphPad Prism, and also how to carry out t-test and ANOVA with GraphPad Prism. What if you want to visualize your data in GraphPad Prism also? So you can click on, let's click on the first data set, and then you will see you have this thing here, this data one. So you can see something like a graph icon here. So when you click on this now, it's going to bring up this interface, and this interface is asking you to now choose the type of graph that you want. So what it is plotting currently is mean with standard deviation. This stuff, they are the error bars, so it's using the standard deviation as like the error bar. You can choose to plot any of these. You can even choose to plot the mean only, but standard deviation is actually the error. You have to show error bar if you want to use standard deviation. If you want to use standard error of mean, it might all be dependent on your supervisor. You can communicate with your supervisor to know like the best measure for variability that he or she wants. So this is one type of chart. If you click on this, then you have another one, then this one, then this one, then this one. There's also, so you just have to go with the best chart. So the best one was this one. Actually, this is very good. And we click on OK now, then you have your chart. So you can actually copy this one like this and paste it in Microsoft Word. You can do a lot of things. You can change the design if you want to do that using this interface. But that's really how to create your visualization in GraphPad Prism. You can type into this place to edit it as necessary. So let's click on data 2, and then click on the chart again to see So here now we have different, this is another chart, that this is the chart for this one. We can see the total depression score for each age group, and then we might want standard, let's say we want standard error of mean, and then that is that. Then we click on OK now. Then we've also created our chart for that. So really that's how to create visualization in GraphPad Prism. Okay, so that is how to carry out t-test, ANOVA, or Mann-Whitney test and Kruskal-Wallis test using SPSS, using Microsoft Excel, and then using GraphPad Prism. Really, carrying out this test is not stressful at all. The most important thing is knowing the right statistical test to use. That is actually more important. And for that, if you make use of this decision tree, you can actually kind of know the right statistical test that you are meant to use. And also you can also discuss with your supervisor, so that you can also be guided appropriately on the best statistical test to actually use also. So this is the end of today's class, and then this is the end of week 2 classes. And we'll meet tomorrow for the live class, and then test will also hold on Sunday. The link for the test will be out on Sunday. Don't forget to register for tomorrow's live class. The link has been attached to this particular video and is also on the resource page. So I'll see you tomorrow in the live class. Bye.